We use these things every single day, but have you ever stopped to think about what's really going on under the hood? At the most basic, fundamental level?
It kind of feels like magic, right? You click, you type, you swipe, and this box of electronics just knows what to do. It calculates, it creates, it connects us, but spoiler alert, it's not magic. What's really happening is this incredibly precise, lightning-fast dance, and it's happening billions of times every single second.
And that dance? Well, it has a name. It's called the machine cycle. This is the absolute core process, the heartbeat, happening inside your computer's brain, the CPU. It's a surprisingly simple four-step rhythm that powers, well, everything. And today, we're going to break it down beat by beat.
All right, so here's what we've got on tap. We're going to look at the computer's heartbeat, see how it's split into two halves, figure out how it gets instructions, and then how it puts those instructions to work. And we'll wrap up with the never-ending loop that makes it all possible.
So let's start with an analogy. I want you to picture your computer's processor, that CPU, as the world's fastest, most obsessive-compulsive librarian. Seriously, every single thing your computer does. That's just our librarian processing one request card after another at an insane speed. And here's the key. Every single request is handled in the exact same way, following four core tasks. And here they are. These are the four beats of the computer's heart. Fetch, decode, execute, and store. That's literally it. Every app you open, every game you play, every single calculation boils down to this one fundamental sequence, just repeated over and over again at a mind-boggling speed.
Okay, now to make this even easier to wrap our heads around, we can actually split these four steps into two main halves. Just think of it like our librarian first prepping the task and then actually doing the task.
And you can see it laid out perfectly here. On one side, you have the instruction cycle. That's all the prep work, fetching the command and figuring out what it means. On the other side, the execution cycle. This is where the action is, carrying out that command and saving the result. So let's dive into that first half, the preparation phase.
Okay, so a good question is, how does our super fast librarian, the CPU, even know what to do next? Well, it all kicks off with that instruction cycle. This is all about finding and understanding the very next command on its massive to-do list.
Step one is to fetch. Pretty straightforward, right? Our librarian needs to go into the stacks, which in computer terms is the main memory, and grab the next request. But this isn't some small-town library. This thing is massive, so it has to know exactly where to look. And here's the cool part, how it finds its way. The CPU has this special little bookmark. It's called the program counter, or PC for short. It's always pointing to the exact address of the next instruction. So the CPU just looks at the bookmark, goes to that address, grabs the instruction, and slaps it onto its desk in a special inbox called the instruction register, or IR, ready to be looked at.
All right, the instruction is fetched. It's sitting in the inbox. Now what? The CPU can't just do it. It has to understand what it's being asked to do first. And that brings us to the decode step. Our librarian is now picking up that request card and reading it carefully to figure out what's what.
And this is where it gets really interesting, how it breaks it all down. The instruction decoder inside the CPU figures out two critical pieces of information. First, the opcode. That's the actual operation, add this, compare that. And second, the operands. That's the data it's going to use. Once it's all sorted out, that data gets shuffled over to a little holding pen called the data register, all set for the main event. Okay, quick recap. Our CPU has fetched the command, it's decoded it, it knows what to do and what data to use. The prep work is done. Now, we shift into the second half of the cycle, where the magic really happens, the execution cycle.
This is it, the moment of truth, the execute step. This is where the command is actually carried out. Our librarian has read the card, knows the task, and now it's time to pick up the calculator and get to work.
And the part of the CPU that does this is called the Arithmetic Logic Unit, or ALU. You can think of it as the mathematical muscle of the whole operation. Honestly, this is where your computer's raw power really shines. The speed of the ALU is what determines how fast your video renders or how smooth the game physics are. It just takes that command and that data and crunch, it does the math.
So, the calculation is done, the task is complete. But wait, we're not finished. That result can't just float around in space, it needs to go somewhere. And that's our final step, storing. Our librarian takes the answer, files it away neatly, and gets ready for the very next request.
So the result from the ALU gets written back into memory, or maybe it gets sent directly to your screen or your speakers. But, and this is absolutely crucial, that program counter, remember our bookmark? It gets updated to point to the address of the very next instruction. This is the little step that keeps the whole engine running, that makes sure the cycle can start all over again instantly without ever missing a beat.
So, let's just say it again. Fetch, decode, execute, store. Fetch, decode, execute, store. It's just a simple 4-step loop. Honestly, it doesn't sound all that revolutionary, does it? But the secret, the quote-unquote magic of modern computing, it's not about how complex the loop is. It's all about the speed.
A modern processor, yeah, the one sitting in your computer or your phone right now, can run through this entire 4-step cycle, get this, billions of times, every single second. That number you see, that's over 3 billion cycles per second. It's a speed that's, well, it's basically impossible for our brains to truly comprehend. So, if there's one thing to take away from all this, it's this. The incredible complexity you see on your screen, it doesn't come from some crazy complicated process. No, it comes from a very, very simple process that's just repeated at an astronomical speed. This relentless high-speed loop is the bedrock foundation that lets us build all this amazing software, turning a simple box of electronics into a portal to, well, anywhere.
And think about it. This fundamental heartbeat, this little 4-step dance, it's in your laptop, it's in your phone, your watch, even your car. It is the universal language of computing. And now that you know how it works, the real question becomes, what are we going to build with it next?